Hello everyone. So let's move to the second question of Leetcode, which is add two numbers. And this question, as we can see, it uses the concept of linked list. So we have to provide the answer in also in the linked list. So we have to use the concept of linked list. And in the linked list, there is some difference here compared to the normal linked list which we might use. Here, every node is represented as a list node. And the difference here is that we will just be provided with the head of every node, every list here, right? Nothing more is there. Like there is no tail, there is no length of the linked list, nothing is provided, only the head of each and every linked list. That is how Leetcode works. So let's try to do one thing. Let's try to finalize the approach which we will use to solve this question. So the thing is, you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. So the thing is, we have to see the number has been provided as 243 in the linked list and each node will have just this val and next. Okay, and the number which we have is 243, but the order is reversed. 342 is the number which is represented by this linked list. As we can see here, the digits are stored in reverse order and each of their nodes contains a single digit. Same here, 564 is there, but the number stored is 465. Now while addition, as we used to do in the childhood time, we have to use a concept here which is very usable here, means we can use it really well. There was a concept called as carry. When two numbers were added and if the number goes above and beyond 10, so we used to keep a carry, right? That is the concept which we are going to use here. So the concept is, if they suppose the two numbers here are 8 and 7, so the result will be 15. So 5 will be used here in the resultant node and 1 will be used in the carry, and which will be used in the addition of this. Suppose it contains 4 and 6 only, so 10 will be the resultant here and 1 will be added as a carry, and this addition will become 11 now. So 1 will be kept here. Now again 1 will be moved to the next. Now 4 and 3 will be added there, which is 7, and 1 will be used in the carry. So carry is the concept which we have to use, and the thing is the remainder and the quotient that needs to be kept in a point here while solving this question. So let's try to gather all the information here. So the two numbers, two linked lists are there and each node will represent a number. So let's try to gather the first two numbers and we can proceed accordingly. So the sum will be L1 dot val plus L2 dot val. Before that, we have to be sure of one thing, that is there any list, is there a possibility which contains numbers less than, means which doesn't have any number. So the list of range is 1 to 100. So there will be at max 100 numbers and at number with 100 digits, and at a min it will be a number with 1 digit. So that is the concept which is being used. So we don't need to worry here, because in the beginning we can use this L1.val and L2.val, because those will never be null. At least one number is there, one digit is there, right? The sum is this, and the carry which is there will be, it will be simply sum divided by 10. Suppose the number which comes out here is 15. So sum 15 by 10 is 1.5 in JavaScript, right? So we have to get to the floor of this value. We can simply do it using the math library, which is a default in JavaScript. Math.floor can be used here. So math.floor for 1.5 it will give 1. Okay, it will just give the floor. That's it, nothing more. So that is what is meant by the carry here. We will get the floor, and sum has to be updated as sum will simply be the remainder when it's divided by 10. Suppose 15 is the number and it is divided by 10. What will be the remainder? The quotient is 1, which is the carry, and 5 is the remainder, right? That is the thing. So we have to use the same concept here. The carry is 1 in that, and the sum will be the remainder in every case. Suppose the number is less than 10, then also if it is 8, any number when divided by 10, the remainder will simply be 8 only, nothing more. So let's use this simple concept, and we will try to iterate through the point or till the point when till the point any of L1 or L2 has digits left in it. So the thing is that it can, since we have three digit number here, but that is not guaranteed. We can see here also one digit number is there, but here we can see one is 7 digits long, other one is 4 digits long. So that can be the pattern here, means any variation can be here, and our solution has to keep all of these scenarios in mind, right? So let's proceed with that. Before going ahead, we have to do one thing, that L1 we need to move every list to the next element, right? Otherwise what happens, we will always be at the same point and adding the same number doesn't make any sense. We have to move it to the next element. So L1 will now become L1 dot next, and L2 will simply become L2 dot next, right? It can be a null or it can be a value there. Nothing is guaranteed, but it can be of any pattern. So let's keep our condition in that way only. If L1 or L2, any of them are present, we will continue iterating through our loop, right? That is the main condition which we will use to go till the end of any number here. Now let's try to decide the result. We need to keep a result variable also, which will return in the end. So result will be new list node. What is the sum here? Sum will be used, and carry will be used of course for the next digit addition. Okay, so the new node has been created with the help of this result. Now we have to do one additional thing here. We need to create a, suppose, current node variable which will point to the current position of the result. Now when we return the result in the end, it should be the head of the result, not any node in the middle or the end, because that won't make any sense, right? As I informed in the beginning, any linked list here we are just given the head of that, and thus we need to return the head of the result node as well, right? That is why I am keeping this second node where the second list, which will be used to iterate through each of the element of the result and create new nodes and add it into the result, right? Now let's do the same operations here also, what we did earlier. As we tried to calculate the sum and the carry, we have to do the same operations here. Now earlier we have seen that only two values were added, but now that will not be the case. Since carry has also come and it will also have a role, we need to add that as well. So if we copy this, we need to do one more thing, that is keep carry in the addition as it has its role, right? It can be 0 or any number if it is there. Now the challenge is L1 could have become null or L2 could have become null. Anyone can become null here. So we need to keep a check for each and every one while before doing this particular addition. Okay. So if L1 is there, then get the value of L1. Otherwise keep 0 here. Similarly, if L2 is there, then get the value of L2 or keep 0 there, right? You get me? If L1 is there, its value. If it isn't there, then 0. If L2 is there, then its value. If it isn't there, then it's simply 0, and carry is added in the end. Let's keep it in parentheses so that we don't mess up with this operator precedence thing, right? So these three additions are done to get the sum. Now carry will be re-evaluated every time. Once carry has been added, its role has ended and it has to be calculated for the next addition, right? So it will simply again be the same calculation will be here. Okay, So let's do that. And also with sum also the same calculation has to be done. So it got copied so that is good. Sum will also be recalculated, right? And now a new node has to be made with this sum. Let node be new list node, and it will be having this sum in that particular node's value, which is the val. This val represents that particular value. Now once this has been put there, we can assign a result. Let's not use result, let's use the current node. Current node dot next is node, and current node will now become its next value only. Current node dot next, right? What it will do, it will move this result to the next element every time. And also we have to do the same operations with L1 and L2. Let's use the if condition here because we don't know whether L1 and L2 are present. If L1 is there, then L1 equals L1 dot next, right? If L2 is there, then L2 equals L2 dot next. Now why are we doing this? If we don't do this, it will just iterate with the same element every time. L1 or L2, if it has executed once, it will execute every time if you don't do this operation. That's why this is mandatory in a while loop, right? Now let's check if there is anything more left. I don't think anything more is left right now. Let's try to run this once and see if it works well. So something has gone wrong here. Let's try it. So we can see there is a edge case here that suppose these two numbers, it added up to anything above 9, right? If it is 10, so the carry here, it can contain a value of 1. Even after this loop has ended, all of the digits have ended, that time also it can carry a value of 1. And if it carries a value of 1, what we need to do, we need to create a new node which will be current node dot next, because in the end current node represents the new node which has been created here. Okay, so its next value can be a new list node containing the value of carry, usually 1, of course, because it can't carry any number more than 1. Okay, so that is the one thing which was missing here, I think, most probably. Let's try to run it. Now we can see all of our edge cases has also passed. All the test cases have passed in the test scenario. Now let's try to submit it and see if all the test cases in the Leetcode pass for this particular question or not. Right. Let's do it. Now we can see we have made actually a very good solution here, and it runs, the runtime is 81% better than others, and memory is also consumed less here, right? So it is a good solution which we can see.